Inscribed angles. We're going to start with a definition of the inscribed angle. An inscribed angle is an angle that is formed by two chords in a circle which have a common endpoint. So here is chord 1, here is chord 2, and then it has a common endpoint, which would be B. The common endpoint forms the vertex of the inscribed angle. The other two endpoints define what we call an intercepted arc. So our intercepted arc is what I've just highlighted in yellow. The measure of the intercepted arc is twice that of the inscribed angle. So there's a relationship between the arc and the angle. For example, if we identify the inscribed angle as x, that means that the measure of the intercepted arc would be 2x. Example 1. What is the relationship between angle ATB and BCT? So first we have to identify that angle BCT is an inscribed angle. That means that we can identify angle BCT as x, and if angle BCT is x, then that means that the intercepted arc of BA would be 2x. Well, if 2x is the arc for 52 degrees, then that means 2x is equal to 52. So we divide both sides by 2, so x is equal to 26. Therefore, the relationship between angle ATB and angle BCT is that angle ATB is twice that of angle BCT. The next question is asking what is the measure of angle BCT. We already found that, and that is 26. And the measure of arc BA is equal to 2 times x, which is 2 times 26, which is 52. So let's look at this from a different perspective. If you look at the diagram, we have an isosceles triangle, and we have an isosceles triangle because we have the center and we have one radius TC and another radius TB. That means that angle TBC is also x because it's an isosceles triangle. The exterior angle theorem, where 52 degrees is the exterior angle of the triangle, states that 52 degrees is equal to the sum of the two opposite interior angles. If we collect like terms and solve for x, we have again proven using an alternative method that angle BCT is equal to 26. Proving again that an inscribed angle is 1/2 of the intercepted arc. In example 1b, we have a circle. Remember, this is circle with center P, and it has an inscribed angle at S. If the measure of the arc, RT, is 47, what is the measure of angle S? So pause and answer this question. So the measure of the inscribed angle is half of the intercepted arc. And that's again because the inscribed angle by definition is half of the intercepted arc. In example 2, if the measure of arc DG is 45.6, what are the angles of measure E and F? Well, the intercepted arc of DG is twice that of angle E and F. Therefore, to find the measure of angle E, it's equivalent to the measure of angle F because they share the same intercepted arc. So we will take that arc of 45.6 and we'll divide it by 2 and get 22.8. The next part says if arc RT, so RT is a semicircle, so that means that if it's a semicircle that this is going to be 180. It's going to be half of 360. Therefore, angle RST is our inscribed angle. So we'll take 180 and we will divide by 2 to get 90 degrees. In example 2b, if the measure of arc ABC is 184 and the measure of arc BCD is 242, what are the measures of the angles of the quadrilateral ABCD? So we can start by finding the measure of angle A, because that's going to be half of arc BCD, and that's given to us in the question. So 1/2 of 242 is 121. So I'm going to put that on the diagram. And the measure of angle D is going to be 1/2 of the measure of arc ABC, and that's given to us. So 1/2 of 184 is 92. So we can put that on the diagram. Now let's identify the arc of ADC in green. And so ADC, if I mark this in green, 360, so the whole circle, minus arc ABC, and that is 184. So we get 176, and arc ADC is twice that of angle B. So the measure of angle B is 1/2 of the measure of ADC. So 1/2 of 176, which is equal to 88. So we'll put 88 on here. And then lastly, the measure of angle C is going to be 360 minus all of our other angles. So 121, 88, 92. So we end up getting 59. Example 2c. If the measure of arc RST, so here's RST, is 164, then what is the measure of angle RVT? So angle RVT is the inscribed angle that relates to arc RST. So therefore, we take 164 and we divide by 2. For the next part of the question, it says if angle SPU So SPU right here is 79. What is the measure of the arc STU? So you'll notice that STU is the arc that relates to the inscribed angle. So we would take 79, which is the angle, and multiply it by 2 to get the arc. So 158 is our answer. Now, what about a case where one chord is actually tangent to the circle? So it says, if a tangent and a chord intersect at a point of tangency on the circle, then the measure of each angle formed is 1/2 of the measure of the intercepted arc. So for example, angle 1 right here is going to be half of the arc AB. And angle 2 right here is going to be half of the arc BCA. So same rule applies. It just looks a little bit different because the one chord is tangent to the circle. So for example 3, line M is tangent to the circle. Find the measure of the red arc or angle. So the red angle, angle 1, is going to be half of the arc. So 1/2 of 130, which is 65. And on the second diagram, find the measure of the red arc. So we're given the angle, and the arc is twice that of the angle. So 125 times 2, so we get 250. Example 3B, line M is tangent to the circle. Find the indicated measure. So the first one, you're going to find angle 1. Why don't you try these on your own? Pause the video and then turn it back on to see the solutions.